everybody, thank you for joining me and welcome to our calculation session today. My name is Mrs Randall and I'm one of the Year 6 teachers here at Glapton. I'm also the maths lead. During the session today, I hope to share with you the progression of the calculation strategies we teach here at the Glapton Academy. I really hope you find it useful. So, to begin with, I'd like you to think back to how you learnt maths at school. As you click through this slide, I'm sure many of these phrases will be familiar to you. But the truth is that these are all incredibly unhelpful when it comes to teaching new and often quite challenging mathematical concepts. So the National Curriculum in Maths has 3 core aims at its heart. These are, firstly, to become fluent in the fundamentals of mathematics. So fluency is all about knowing the facts and being able to recall them quickly and accurately. Aim 2 is to be able to reason mathematically. Reasoning is being able to explain, justify or prove answers or choice of method using mathematical language. And the final aim is to be able to solve problems by applying the mathematics to a variety of routine and non-routine problems. So this statement has been taken directly from our calculation policy. Our aim at the Glapton Academy is for all children to enjoy mathematics and have a secure and deep understanding of fundamental mathematical concepts and procedures when they leave us and go to secondary school. We want children to see the mathematics that surrounds them every day and enjoy developing vital life skills in this subject. Some of the key points and main aims of our calculation policy at Glapton are to ensure consistency in the teaching and learning of maths across the school, ensure that all children are using the formal written calculation methods by the time they leave us at the end of Year 6, to set all children learning which appropriately stretches and challenges their ability, and finally, to ensure that all children are enabled to learn in a way which maximises the chances of success. So something else I'd like to talk to you about today are the principles of the CPA framework, which we incorporate into the teaching of maths at Glapton. This is the concrete pictorial abstract approach, which some children may know as do it, draw it and write it. This is an approach which has been recognised to be at the heart of mathematical mastery. We all know that many children and adults can find maths difficult because it's just so abstract. The CPA approach builds on children's existing knowledge by introducing abstract concepts in a concrete and tangible way. It involves moving from concrete materials to pictorial representations to abstract symbols and problems. However, it's important to note this is not always a linear progression, and we use the CPA approach to scaffold the learning for as long as the children need it. Through this approach, our students deepen their understanding by experiencing and handling physical maths, representing concepts using pictures and visuals, and making connections between different representations. After all, maths lessons aren't about teaching tricks, they're about giving pupils the tools to truly understand the problem in front of them. So as with all operations, we always like to begin with giving our students things, real things that they can manipulate. We give our children lots of hands-on experience with equipment to help them become familiar with what each operation means before using abstract written calculation methods. With addition, after this initial stage, children will progress onto pictorial methods, such as counting on a number line and using base 10 representations, as shown in the diagram below. Here is an example of how the formal written method of addition progresses through the school. So it begins, as you can see on the left-hand side, with the pictorial representations. You can see clearly how the exchange has been made from the ones into the tens. This will then progress onto the middle section, where 8 plus 6 equals 14 has been written, the 70 add the 50 equals 120 has been written, the 400 add the 200 has been written, and then these numbers have been totalled, leading to the final demonstration on the right-hand side. As I mentioned on the slide before last, with each operation we begin by allowing children to work with real-life objects first. I chose these diagrams to show you how children will begin by physically removing objects or crossing out pictorial representations. When children get to Year 2 or 3, they'll need to start considering, depending on the calculation, whether to count backwards or forwards. For example, numbers which are further apart, such as 84 subtract 25, it would be more efficient to count back from the larger number. Whereas numbers which are closer together, for example 84 take away 79, it would be much simpler to count forwards from the smaller number. Here are some examples of what this might look like on a number line. Children will be introduced to the column method layout as early as Year 2. Here's an example of the progression in this formal written method. I've chosen this example specifically as it demonstrates an exchange. I've deliberately underlined this terminology as many of you may have heard this previously referred to as a borrow. 6 take away 7, you can't do, so you borrow 1 from the 7. Now this can't be correct, as to borrow insinuates you're going to give it back, which we're not going to do. Instead, we're going to exchange 1 10 for 10 ones. This can be shown clearly in the pictorial representation on the left-hand side. In the early stages of learning multiplication, we might see 6 multiplied by 5 represented in a variety of different ways. Here we have Numicon, in red at the top, an array, a bar model, and a number line at the bottom. Here is an example of the progression in short multiplication. Here we are using the question 38 multiplied by 7. On the left we have multiplied 8 by 7, the answer 56 is written below. Then we have calculated 30 by 7, which equals 210. The final step was to total these two numbers, which gives us 266. This method helps the children to develop a rich understanding of the process before they progress onto the common method. Here is an example of how we would solve a long multiplication question. Here we have 45 multiplied by 37. For those of you who would like to hear more about how this method is carried out, I'm just going to talk you through it. So first, if we were to cover up the 30 in the question, it looks exactly like the short multiplication that we just learnt before. So we've done 5 multiplied by 7, which gives us 35. I've written the 5 and regrouped the 3. And then we've done the 4 multiplied by 7, which gives us 28, plus the 3 gives us the 31. Now I'm going to move across to multiplying the 45 by the 30. Now because this is 30 and not 3, I need to put my placeholder down, and that's the 0 that you can see on the next row. I then continue as I did before. I've multiplied the 5 by the 3, which gives me the 15, regroup the 1, and I've done the 4 multiplied by the 3, plus the 1, which gives me the 13. I've then totaled these numbers. 5 plus 0 is 5, 1 plus 5 is 6, 3 plus 3 is 6, and then 1 in the thousands column on its own. Gives me the total of 1,665. So there are two ways in which we support the children with their division at Glapton. The first is sharing. When we do 6 divided by 2, this means 6 shared into 2 groups. The other is grouping. When we do the same calculation, 6 divided by 2, this translates as how many groups of 2 are there in 6. So here are some examples of what division could look like on a number line. An example of counting on a number line without and with a remainder is shown here. And at the bottom, this is typically found in lower Key Stage 2. This is how we count on a number line using multiple chunks. So here's an example of a short division question. We've got 615 divided by 5 here. You can see underneath the 6 I've put the 6 spots, and this is just an example of what I might do initially to support the children's understanding with pictures. So underneath the 600s I've used the 6 counters to represent the 600s, and the question I'd ask is how many 5s can I get into that 6? You can see that I've circled the 6 counters, that's one group, put the one above, and the one that's left over I've regrouped into the following column. This then becomes 11, which I'd then support with another 11 spots if the children needed it, and I'd continue with this until the children were sound in their understanding. So here are just some of the many ways in which you can support your child at home with their maths. Firstly, involve them in real life maths problems. Whether that be selecting money at the shop, working out what time the chicken needs to come out the oven, or working out the best deal on car insurance, maths is everywhere. Help your children to see its value and importance. Secondly, talk about maths and talk about it positively. Get them to explain what they're doing, ask them questions and show you're interested in their maths. Stick with the methods in this PowerPoint. I know it can be tricky, especially if you've learnt a different way, but consistency between school and home is key here. Play games, anything that involves numbers, point scoring in Scrabble or matching numbers in dominoes for the younger children. And talk to them about their homework. Ask them what they're learning. Can they explain it to you? Can they demonstrate a particular method that they've learnt? Can they prove to you that they found a solution? Practice maths whenever you can. Counting, number bonds, times tables, even just looking for numbers, whether that be odd and even house numbers or negative numbers in the freezer. And finally, speak to us. If you have any questions or you'd like more specific guidance on how you can help your child, please feel free to speak to your child's class teacher, either through the office or just pop a note in their partnership book, and we'll be more than happy to give you some suggestions on things to work on. So that's it from me today. Thank you so much for joining me in our calculation session. I really hope you found it to be informative and beneficial. And if you have any further inquiries on how we teach maths at Glapton at all, please do not hesitate to contact me via the school office and I'll do my very best to help you. Thanks again.